So what is an inequality? Inequality is a statement that one quantity or expression is greater than, less than, greater than, equal to, less than or equal to. I guess technically it would be, you could say not equal to also, but those you can solve just like equations. A linear inequality is one that can be written this way, and doesn't mean it is, can be, doesn't mean it is, doesn't mean it is, it just means it can be. Or of course a is not 0, because then it wouldn't be a linear inequality anymore. And of course that symbol can be any of the usual symbols: greater than, equal to, less than or equal to. Okay, so how do we solve them? Same way we solve equations. Get rid of any fractions, distribute to get rid of parentheses, combine like terms, get the x on one side, constant on the other, and then we divide both sides of the inequality by the coefficient of the variable. And here's the important piece. That's why I made it red. Reverse the inequality symbol if the number is negative. We talked about this in the beginning of the chapter when we were just doing a review. We're taking this to a little more higher level now. And check the solution. Does it make sense in the context of the problem? So let's do a quick problem here. 5x minus 1/5 is less than or equal to negative 2 plus x. Don't like that fraction. Let's get rid of it. 5. Let's make sure we distribute. And you have seen me forget to distribute before, so 5 times 1/5 is 1. Okay, let's get our x's on one side. I'm going to go negative 5x plus 1. So it looks like I have 20x is less than or equal to negative 9. X is less than or equal to negative 9/20. So that means, could x be 1? Would 1 make this correct? Let's find out. 5 times 1 is 5 minus 1/5. So what's that? 4.8 is less than or equal to negative 2 plus 5. Oh, 1. Sorry. Negative 1. That didn't make any sense. Oh, negative 1. I'm sorry. Brain. Okay. So less than negative 9/20. So I'm going to actually draw that. And then now you'll see why we draw these things out. So negative 9/20. I want you to think about right here would be 0. And so this is not negative 9/20. So negative 1 is over here somewhere. Probably a little farther, probably over here. So negative 1 would be in this region. So I'm going to go 5 times negative. So negative 5 minus 1/5. So it's negative 5.2. Is that less than or equal to negative 2 plus negative 1? And it is. So this is probably correct. Now you can also check the exact number just to make sure. I'm not going to worry about that right now. Okay. Example for profit. We talk a lot about this stuff. For an electronic reading device, okay, it's a Kindle, all right. The weekly revenue and weekly cost in dollars are given by, revenue is 275x and the cost is 150x plus 12,000 respectively. X is the number of units produced and sold. For what levels of production will a profit result? So a profit occurs when revenue you take in more than you put out. Makes sense? My revenue is more than my costs. So I'm making money. I'm making a profit. A profit is occurring. So to rewrite these, that's 275x is greater than 150x plus 12,000. So what do? Subtract 150x from both sides. Let's see, I get 125x is greater than 12,000. X is greater than divided by 125, 96. And cost in dollars, X is the number of units. So X has to be more than 96 units in order for us to make a profit. I can check this using 96 exactly to see if this would be correct as an equation. 96, that's funny when it does that. 96 times 275. That would make me 26,400 in revenue. 150 times 96 plus 12,000. That would make me 26,400 in costs. Therefore, I have to make more than 96 units in order to have this happen. So what if I made 100 units? Would it work? Well, this would be 27,005. And this would be 15,000 plus, so this would be 27,000. So yes, I would make a profit of $500 if that were the case. So this is correct. Okay. So here's a body temperature example. So if a dog has a temperature over 101, it's said to have a fever. So what's Celsius temperature? So we're traveling through Canada with our dog now, and all we can get is a Celsius thermometer. So what Celsius reading would mean that the dog has a fever? Let's find out. So here's our equation. Subtract 32 from both sides, greater than or equal to 101, come on, 101 minus 32, 69. I'm just going to multiply both sides by 5/9. Just get rid of everything at once. C is greater than or equal to times 5 divided by 9. 38.3 degrees. Well, that's repeating, but so if the dog has a fever, if its Celsius temperature is approximately 38.3 degrees or higher. Okay, so let's talk about how we would go about doing something like this on our calculator. Now it's a little bit more difficult because we can do equations on the calculator. So using the intersection method, we're just going to put the left and the right side of the inequality into y1 and y2 and graph the equation. So we'll get something like this, right? Then we have to find that point of intersection. So we're going to use intersection. So remember that's 5. We go second trace, which is calc. Go to 5 intersection. We hit enter, enter, then we put a guess, enter. And that should give us that x. Then you check the values on each side of that point, I'm calling that point A, at x equals A, to see which side makes the inequality true. And then you have it. So let's do an example of this. So here we have y1 is going to be, in parentheses, 3x minus 1 div 4. And clear that out. So 3x minus 1 divided by 4. And y2, the other side, is going to be 2x plus 5 divided by 5. Because remember, the fraction line has an understood parenthesis, which we kind of lose when we put them in the calculator. 2x plus 5 div 5. Okay, so now what I'm going to do is I'm just going to zoom this to standard. See if I can get my intersection in there. Okay, looks like it's in the first quadrant. I can zoom this to the first quadrant. I don't generally do it. I don't want to zoom it in. I guess I can. We can zoom in a little. And what's nice is you can actually zoom right where the intersection is, if you like. I'm just moving these around. So I'm zooming this in right on top of the intersection. And you can see it even better. Look at that. Okay, I zoomed that in right on the intersection. So then, second calc, intersect number 5. First curve, second curve, guess. I'm right on top of it, so. And there's my intersection. Okay. Not sure if I want that. Let's see if I can get this to do a fraction. There we go. So x is 25 over 7 and y 17 over 7. Don't really care what y is. So I have to figure out now, does this mean x is greater than or equal to 25 over 7 or less than or equal to 25 over 7? So I need to pick a number on one side of this. Well, what's our favorite number? Is 0. That's my favorite number. That's easy. So what I'm going to do is I'm going to check my answer. So 0 minus 1 over 4 is greater than 2 times 0 plus 5 over 5. So negative 1/4 is greater than or equal to 1. Is this true? No. Therefore, this thing can't be 0. So x has to be greater than or equal to 25 over 7 in order for this to be true. Because it can't be less than that. Because if it was less than that, then 0 would be okay, and 0 is not okay. So that we know that the direction of the inequality stayed the same. It's greater than. Okay.